The ground you stand on is lying to you. Beneath it, something has been waiting. It has waited for thousands of years. It is invisible. It is the most powerful force on this planet. It has buried continents in ash. It has blotted out the sun. It may have nearly ended our species. And you are standing on top of it. Right now, one is stirring beneath 3 million people. No warning system can outrun it. No technology on Earth can stop it. No force in nature can match it. This is the story of supervolcanoes. "74,000 years ago, the island of Sumatra cracked open. There was no warning. Deep beneath the tropical jungle, a magma chamber the size of a small country had reached its breaking point. The crust above it shattered, and what followed was the largest volcanic eruption in the last 2 million years. The explosion launched a column of rock, gas, and ash more than 40 kilometers into the sky. Pyroclastic flows, avalanches of superheated gas and pulverized rock cascaded down the flanks at 1100 degrees Celsius. They moved at 320 kilometers per hour. Nothing in their path survived. Within hours, ash began falling across South Asia. Within days, it had spread across the Indian Ocean. Deposits 10 centimeters deep blanketed the Indian subcontinent, thousands of kilometers from the eruption site. The sky went dark. Sunlight dimmed as sulfur dioxide flooded the stratosphere, forming a veil of acid droplets that wrapped the planet. Global temperatures may have dropped by as much as 3 to 5 degrees Celsius. The eruption left behind a crater, a caldera so large it eventually filled with water. Today, it is Lake Toba, 100 kilometers long, 30 kilometers wide. You can see it from space. For decades, scientists believed this single eruption nearly ended the human species. In 1998, anthropologist Stanley Ambrose at the University of Illinois proposed a theory. It would reshape the way we think about our own survival. He called it the Toba catastrophe theory. His argument was built on a strange fact about human genetics. Every person alive today, all 8 billion of us, shares an almost identical genetic blueprint. We are, genetically speaking, remarkably similar to one another, far more similar than we should be. A troop of 50 chimpanzees living in the same forest contains more genetic diversity than the entire human race. Something, at some point in our past, reduced our numbers to almost nothing. A population crash so severe that the survivors carried only a fraction of the genetic variation their ancestors once held. They rebuilt the species from almost nothing. Ambrose believed Toba was responsible. He proposed that the eruption triggered a volcanic winter lasting 6 to 10 years. Plant life collapsed, food sources vanished. The human population, scattered across Africa and parts of Eurasia, crashed to as few as 3,000 to 10,000 breeding individuals. A handful of small groups huddled in tropical refuges, clinging to survival in a world that had gone cold and dark. Everyone alive today, according to this theory, descends from those survivors. Every civilization, every language, every face you have ever seen, all of it tracing back to a few thousand people who made it through the worst catastrophe our species has ever faced. For nearly 2 decades, the Toba catastrophe theory was widely accepted. It appeared in textbooks. It was cited in hundreds of papers. It became the default explanation for the bottleneck in our genetic past. But then other scientists started looking closer. They went to the sites nearest to the eruption. They dug through the ash layers. And what they found did not match the theory at all. We will return to what they discovered. Did this eruption nearly erase the human species? Or did scientists spend 30 years chasing a ghost? The answer changes everything we think we know about what supervolcanoes can do. But first, we need to talk about the one that is waking up right now. Supervolcanoes are not relics of the ancient past. One of them is restless right now. 8 miles west of Naples, Italy, there is a caldera called Campi Flegrei, the Phlegraean Fields. It stretches 8 miles across. It does not look like a volcano. It looks like a coastline dotted with towns, harbors, and apartment buildings. More than 500,000 people live inside it. Most of them have lived there their entire lives. But beneath their feet, this caldera holds a violent history. 39,000 years ago, it produced one of the most catastrophic eruptions in European history. The blast ejected roughly 300 cubic kilometers of material. Ash from that single eruption has been found in Greenland, 4,500 kilometers away. Some researchers believe it contributed to the extinction of the Neanderthals. The last eruption was smaller. It happened in 1538, when a new mountain, Monte Nuovo, rose from the ground in a matter of days. Then the caldera went quiet. For nearly 5 centuries, it was silent. That silence ended in 2005. Since then, the ground beneath the town of Pozzuoli has been rising. Slowly at first, a few centimeters per year, then faster. As of today, the land has risen by approximately 1.4 meters, and the earthquakes have followed. In 2024, the caldera produced a magnitude 4.4 earthquake, the largest any instrument had ever recorded there. Months later, another struck at magnitude 4.6. Earthquake swarms have become routine. In February 2025, a single swarm produced 282 earthquakes in a matter of days. Buildings in Pozzuoli have been damaged by the continuous shaking. Some residents have lost their homes. Everyone in the red zone receives an alert on their phone every time a tremor exceeds magnitude 1.5. In October 2024, the Italian government ran a national evacuation drill. Over 700 civil protection operators, 1,500 citizens, a simulated eruption scenario moving through yellow alert to orange to red. They were practicing for the day they might have to evacuate an entire region. And here is what makes Campi Flegrei so deeply unsettling. Scientists cannot agree on what is happening beneath it. A December 2025 study found that the earthquake swarms do not increase predictably as the ground rises. They follow a pattern no existing model had predicted. Is magma rising toward the surface? Or is something else entirely driving the unrest? The answer, when it comes later in this video, will be the most surprising finding in the entire story. But to understand what Campi Flegrei is capable of and why scientists are so worried, we first need to understand what a supervolcano actually is. Scientists measure volcanic eruptions on something called the Volcanic Explosivity Index. It is a logarithmic scale. Each step up is 10 times more powerful than the one below. If a VEI 5 eruption, Mount St. Helens in 1980, is a firecracker, then a VEI 7 is a stick of dynamite. A VEI 8 is a bomb that levels the building. A supervolcano is any system capable of a VEI 8 eruption. That means ejecting more than 1,000 cubic kilometers of material in a single event. And here is the first thing that makes them so dangerous. They do not look like volcanoes. When a supervolcano erupts, so much magma drains from beneath the surface that the ground above collapses into the void. Imagine drinking a thick milkshake through a straw. The liquid pulls away from below, and the surface caves in. What remains is not a mountain. It is a depression, a caldera, sometimes 50 miles wide. Yellowstone's caldera stretches 40 by 25 miles. Most visitors to the park do not realize they are standing inside a volcano. The second misconception is about what lies beneath. A magma chamber is not an underground lake of liquid lava. It is more like a hot sponge, mostly solid rock with pockets of melt threaded through it. Yellowstone's upper magma chamber is roughly 9% molten. The rest is solid. You could not pour it. You could not swim in it. But that 9% is enough. Because a supervolcano erupts when the pressure inside that chamber exceeds what the crust above can hold. The magma generates heat. The heat generates gas. The gas expands. And when the pressure crosses a threshold, the crust does not bend. It shatters. Every model scientists have built to predict when that threshold is reached has eventually been proven wrong. And the clearest proof of what happens when it breaks came 2 centuries ago on a volcanic island in Indonesia. April 5th, 1815. The island of Sumbawa in the Indonesian archipelago. Mount Tambora, a dormant volcano standing more than 4,000 meters tall, begins to rumble. A massive explosion tears open the summit, launching a column of ash 18 miles into the sky. 800 miles away, Thomas Stamford Raffles, the British Lieutenant Governor of Java, hears the blast at his residence. He assumes it is cannon fire. Fearing a nearby village is under attack, the commander of Jogjakarta dispatches troops. Officials along the coast believe a ship is in distress and launch rescue boats. No one suspects a volcano. Over the next several days, the eruptions subside. Ash drifts across Java. The air grows thick and still. Raffles returns to his routine. Then, on April 10th, Tambora detonates. The eruption is the largest in recorded human history. A VEI 7. 100 cubic kilometers of rock, ash, and pumice blast into the atmosphere. The eruption column punches 43 kilometers into the stratosphere. The mountain loses more than 1,000 meters of height in a single night. Rivers of superheated ash cascade into the sea, triggering tsunamis nearly 15 feet high. 10,000 people on Sumbawa die instantly. In the months that follow, tens of thousands more die of starvation and disease on the surrounding islands. but the true devastation has not yet begun. High in the stratosphere, a veil of sulfur dioxide particles begins circling the globe. By winter, this invisible curtain has wrapped the entire planet, reflecting sunlight back into space. The world begins to cool. The year is 1816. History will call it the year without a summer. On June 6th, snow falls in Albany, New York. In Cabot, Vermont, snow lies 18 inches deep on June 8th. Frost kills crops in New England in June, July, August, and September. Farmers plant their fields and watch them die 4 months in a row. Across the Atlantic, the situation is worse. In Ireland, it rains without stopping for 8 weeks. The potato crop fails. Famine follows. Across northern and central Europe, cold rain and early frost destroy grain harvests and prevent hay from being gathered. In economies that run entirely on animal power, the failure of feed crops is catastrophic. In China's Yunnan province, flooding and cold weather destroy 3 consecutive growing seasons. A 3-year famine grips the region. Farmers who survive begin planting opium poppies in place of food crops that can no longer be relied upon. In the Bay of Bengal, the eruption disrupts the monsoon cycle. In the altered conditions, the cholera bacterium mutates. A new strain of Bengal cholera begins to spread. It will kill tens of millions of people in a global pandemic lasting until 1823. In Switzerland, on the shores of Lake Geneva, the cold rain refuses to stop. A group of writers, trapped indoors for days, challenge one another to write ghost stories. One of them is an 18-year-old named Mary Shelley. She writes Frankenstein. A single eruption on a single island is rewriting economies, borders, and literature simultaneously. In the northeastern United States, families who have endured 2 failed growing seasons make a decision. They abandon their farms and head west. The exodus is so large that Indiana becomes a state in 1816. Illinois follows in 1818. The eruption of a single volcano 10,000 miles away reshapes the map of America. And the entire world suffers because of one eruption that lasted a few days on a single island in Indonesia. This is the critical thing to understand. Tambora was a VEI 7, 1 step below the supervolcano threshold. On the logarithmic scale, a VEI 8, a true supervolcano, releases 10 times more energy, 10 times more ash, 10 times more sulfur, 10 times more destruction. Everything Tambora did to the world in 1816 was a fraction. A preview, 1/10 of what a supervolcano is capable of. And until very recently, scientists believed they understood how these systems worked. They were wrong. In April 2015, a team of seismologists at the University of Utah published a study in the journal Science. They had spent years using earthquake waves to image the structures beneath Yellowstone National Park. Scientists had long known about a magma chamber sitting 3 to 9 miles below the surface. That chamber was enormous, 2,500 cubic miles of hot, partly molten rock. But the Utah team found something beneath it. A second reservoir. Deeper, 12 to 28 miles below the surface, and 4.4 times larger than the chamber above. The hot rock inside this newly discovered reservoir would fill the Grand Canyon 11 times over. Lead author Xinhua Huang said the team had done something no one had done before. For the first time, they had imaged the continuous volcanic plumbing system under Yellowstone. From the mantle plume deep in the earth, up through the lower reservoir, into the upper chamber, and all the way to the surface. The complete picture. The discovery solved a mystery that had nagged researchers for years. Yellowstone's geysers and hot springs release far more carbon dioxide than the upper chamber alone could produce. Now they knew where the excess gas was coming from. There was a second engine beneath the first, and they had never seen it. But the Utah team was careful to stress that the hazard had not changed. The probability of an eruption remained 1 in 700,000 per year. Then, 2 years later, a second study made that reassurance harder to hold. In 2017, researchers at Arizona State University examined mineral crystals preserved in fossilized ash from Yellowstone's last massive eruption, 640,000 years ago. They wanted to know how long the magma buildup had taken before the system blew. Previous estimates said centuries, perhaps thousands of years. The crystals told a different story. The critical changes in temperature and composition had built up in a matter of decades. Not centuries, decades. Study co-author Hannah Shamloo said it plainly. It is shocking how little time is required to take a volcanic system from being quiet and sitting there to the edge of an eruption. The chambers are bigger than we thought. The timelines are shorter than we thought. And in March 2026, scientists in Japan discovered something about supervolcanoes that may be the most unsettling finding yet. We will return to what they found, because right now, there is a more urgent question. If the chambers are bigger than every previous model predicted, and the buildup can happen in the span of a single human lifetime, what happens when the next one goes? A full-scale super-eruption at Yellowstone would begin with the ground shattering across a caldera 40 miles wide. Within minutes, roughly 90,000 people in the immediate blast zone would be dead. Superheated pyroclastic flows would incinerate everything within a radius of tens of miles. But the initial blast is not the catastrophe. The catastrophe is what comes next. A column of ash and gas would punch through the stratosphere, rising higher than commercial aircraft fly. And then the ash would begin to fall. Not soft gray fireplace ash. Volcanic ash is something else entirely. It is pulverized rock and glass, tiny shards with jagged edges heavy enough to collapse a roof. Within days, cities across North America would be buried. Several centimeters of ash in Chicago, in Seattle, in San Francisco. That is enough to shut down a city. Ash clogs jet engines. It shorts electrical systems. It contaminates water supplies. It buries crops not in a blanket, but in a layer of powdered stone that nothing can grow through. The American heartland, the breadbasket that feeds much of the world, would lose an entire growing season, at minimum. And the ash is only the beginning. A Yellowstone-scale eruption would inject roughly 60 megatons of sulfur dioxide into the stratosphere. These particles would form a thin veil of acid droplets that circles the planet. Imagine pulling a curtain across a window. The sun still shines behind it, but less light reaches the room. The room gets cold. Now imagine that curtain wrapping the entire Earth. Global temperatures would drop 3 to 5 degrees Celsius. In the first year alone, the drop could reach 10 degrees. 3 degrees does not sound like much. It is enough to end agriculture as we know it. Growing seasons would shorten by weeks. Frost lines would shift by hundreds of miles. Harvests would fail across Europe, Asia, and the Americas simultaneously. Remember what a single degree of cooling from Tambora did in 1816. Snow in June. Famine across 2 continents. A cholera pandemic that killed tens of millions. A supervolcano produces 10 times that cooling, for years at a time. The Geological Society of London assessed the consequences in a formal report. They did not soften their language. The effects could result in the devastation of world agriculture, severe disruption of food supplies, and mass starvation. These effects could be sufficiently severe to threaten the fabric of civilization. And here is what separates a supervolcano from every other existential threat. An asteroid can be tracked. In theory, it can be deflected. A pandemic can be contained with quarantine and vaccine development. A nuclear war requires a human decision that can, in principle, be reversed. A supervolcano offers none of these options. There is no deflection mission. There is no shield. There is no off switch. The same report stated it bluntly. Even science fiction cannot produce a credible mechanism for averting a super eruption. When the pressure exceeds the strength of the crust breaks. That is geology. It is not negotiable. Now bring this back to the present. Campi Flegrei, the same system that produced the Campanian ignimbrite eruption 39,000 years ago. The blast that sent ash to Greenland and may have ended the Neanderthals. That system sits beneath the western edge of Naples. 3 million people live within its reach, and it is not quiet. 20 years of rising ground and intensifying earthquakes. Buildings in Pozzuoli have cracked from the continuous shaking. Residents are not reading about this in the news. They are feeling it in their walls at night. Their phones vibrate with alerts every time the ground shifts above magnitude 1.5. They are living inside a supervolcano that has already demonstrated what it can do. And no one can tell them with certainty whether the shaking will stop or whether it is the beginning of something they cannot outrun. We left a question open at the beginning of this video. 74,000 years ago, the largest eruption in 2 million years tore open the island of Sumatra. For nearly 3 decades, scientists believed it almost ended the human species. It is time to return to that question. In the years following Stanley Ambrose's 1998 theory, researchers began going to the places closest to the eruption. They went to India. They went to Sumatra itself. They dug through the ash layers. And above and below those layers, they found the same thing. Stone tools, evidence of human activity, signs of life continuing. The people who lived nearest to the eruption had survived it. Then the climate models were refined. New simulations showed that the cooling was not uniform. Large parts of the southern hemisphere experienced little to no temperature drop at all. The volcanic winter, if it happened, was regional, not global. Then the geneticists weighed in. Multiple analyses of the complete human genome searched for a bottleneck that matched the timing of the Toba eruption. They could not find one. The population decline was real. The genetic evidence confirms it, but the timing does not align with Toba. The bottleneck may have been caused by the out-of-Africa migration itself, a small group of a few thousand people leaving the continent, carrying only a fraction of Africa's genetic diversity with them. The eruption was real. It was enormous. It was the largest in 2 million years. But it probably did not nearly end our species. The first time scientists tried to connect a supervolcano to mass extinction, they got the story wrong. The more they studied, the more the evidence fell apart. And yet, the mystery remains. Something reduced the genetic diversity of 8 billion people to less than that of 50 chimpanzees. We still do not know what. We just know it was probably not Toba. That pattern of certainty dissolving under closer examination defines everything we know about supervolcanoes. And it continued in March 2026, when researchers at Kobe University in Japan published a study in Communications, Earth and Environment. They had spent years imaging the structures beneath the Kikai caldera, a mostly underwater volcanic system south of the Japanese mainland. 7,300 years ago, Kikai produced the largest eruption of the current geological epoch. Scientists assumed that after an eruption of that scale, the magma system would be spent, drained, exhausted, dormant. It is not. The Kobe University team confirmed a large magma reservoir sitting just 2.5 to 6 kilometers below the sea floor, directly beneath the site of the ancient eruption. But the magma is not left over from 7,300 years ago. Chemical analysis of a lava dome forming at the center of the caldera shows a different composition from the previous eruption. This is new magma, arriving from below. The system that produced the largest eruption of the Holocene is reloading, and the researchers proposed that this process is not unique to Kikai. It may be common to all giant caldera systems: Yellowstone, Toba, Campi Flegrei. Supervolcanoes do not erupt and die. They erupt and reload. That finding should sit with you for a moment, because it means the threat is not behind us. It is permanent. But this is not where the story ends, because there is one scientist who believes the ending can be rewritten. Her name is Tiziana Vanorio. She grew up in Pozzuoli, Italy, the town at the center of Campi Flegrei. In the early 1980s, when she was a child, the ground beneath her home began to rise. The caldera was waking up. Earthquake swarms shook the town day and night. The harbor grew so shallow that ships could no longer dock. A magnitude 4 earthquake struck, followed by thousands of smaller ones. 40,000 people were evacuated from Pozzuoli. Tiziana Vanorio was one of them. She was a child. She left her home, her school, her street. She did not know if she would come back. Decades later, she became a geophysicist at Stanford University. And in 2025, she led a study that may have changed the future of Campi Flegrei. Her team used underground imaging and laboratory experiments to investigate what is driving the caldera's unrest. The assumption for decades had been magma, hot rock rising toward the surface, building pressure, cracking the crust. Vanorio's team found something different. The unrest may not be driven by magma at all. It may be driven by water. Pressurized water accumulating in a sealed geothermal reservoir beneath the caldera. Rainfall seeping into the ground, slowly building pressure over years until the rock above it fractures, producing earthquakes, ground uplift, and the rumbling sounds that have become routine for the people of Pozzuoli. If this is true, the implications are extraordinary. Because water can be managed. Groundwater levels can be lowered. Runoff can be channeled. For the first time in the history of volcanology, a scientist has proposed that a supervolcano's unrest could be reduced by human intervention. Not just monitored, not just measured, managed. Vanorio said it herself. This project is my goal as a citizen now, not just as a geophysicist, because the study suggests that unrest can be managed rather than just monitored, opening the way to prevention. A girl evacuated from a supervolcano as a child grew up to become the scientist trying to save it. That is not a footnote. That is the most important thing happening in volcanology right now. None of this means the danger has passed. Yellowstone remains one of the best monitored volcanoes on Earth. The Yellowstone Volcano Observatory watches it continuously. Seismic sensors, satellite imaging, geochemical sampling. Scientists expect weeks to years of precursory activity before any supereruption. The annual probability remains 1 in 700,000. But probability is not certainty. And we have been studying these systems for barely a century. In that century, we discovered chambers we never knew existed. We learned that the buildup can happen in decades, not millennia. We found that erupted calderas refill with new magma steadily over thousands of years. Every decade, we discover that we understood less than we thought. The ground beneath you is 4.6 billion years old. It has cracked open before. It will crack open again. Not today, probably not in your lifetime. But the Earth does not work on your schedule. It works on its own. And every day you walk across its surface, you are crossing a thin, quiet crust of rock, beneath which something immense is turning over in its sleep. We do not call them supervolcanoes because they are large. We call them that because they are patient. And the ground you stand on has never once asked your permission.